Chapter 7: Commonly used laboratory glasswares and equipments. Glassware used in laboratory has to be such that it should be resistant to corrosive acids and alkalis, should be able to withstand heating, have a low coefficient of expansion so that it is able to deliver the same volume when cold or hot. There are different types of glass material used, but the most common is borosilicate glass, which has all the property desired in a glassware for laboratories. These days, the use of plastic labware has increased. They are shatter-proof, heat-resistant, and transparent. Some of the laboratory wares can be autoclaved. The most common are high-density polyethylene (HDPE). Many of disposable labwares are made using this, and polypropylene, resistant to heat or acid, and can be reused. When accurate amount of reagent or solution have to be measured, pipettes, burettes, or volumetric flasks are to be used. Measuring cylinders are used for approximate measurements. Pipettes are of different types and of various capacities. The common ones are volumetric valve pipette, graduated pipettes, Oswald pipettes, and micro pipette. Volumetric, graduated, Oswald, micro. तो सबसे पहले volumetric pipette. Volumetric pipettes have one mark and it delivers exactly the amount written on it. The liquid is sucked up to the mark and is slowly delivered into any other container. When all the fluid has run out, the tip of the pipette is touched to the side of the container so that some more liquid passed out, leaving a small amount at the tip. Such pipettes are never blown out. Volumetric pipette. Second है graduated pipette. Graduated pipettes are used for measuring intermediate quantity such as 8 ml to 3 ml or 0.6 ml and so on. Last drop at the tip of this pipette should be blown out if measurement up to the tip is wanted, and provides the pipette is graduated up to the tip. If the pipette has a double frosted line near the top, then in this type of pipette, one has to blow out the last drop. If there is single line, then it is never blown out. Graduated pipette marking. Oswald pipettes are meant to measure thick, viscous liquid such as blood. It has only one mark. Suck up the liquid to be measured up to the mark, and then gently let this liquid pass into another liquid and blow gently. Against Again suck up the second liquid and let it go into the container again. In this way, wash the pipette 3 times. Volumetric flasks are meant to make solution up to any fixed volume such as 50 ml, 100 ml, 250 ml, or 1000 ml. When accuracy is not much required, measuring cylinders or graduated cylinders may be used in its space. Graduate cylinders are narrow, straight sided vessels that are used to measure a specific volume. They are made of either plastic or glass and ranges from 5 ml to 7 liter. volumetric flask. Beaker are made of borosilicate glass or HDPE. They are used for general mixing and preparation of non-volumetric liquid reagent. They are wide mouth, straight sides. Their volume or breaking are not accurate. Beaker are made of borosilicate glass or HDPE. They are used for general mixing and preparations of non-volumetric liquid reagents. They are wide mouth, straight sides. Their volume marking are not accurate. Beaker HDPE. Auto pipettes. Mouth pipetting using conventional glass pipette has its hazard and is being replaced by the use of micropipettes and autopipettes. A pipette is a lab device used to measure out or dispense a small amount of liquid in volumes of milliliters, ml or microliters, μl. They have the advantage of their ease of use and their precision. Autopipettes save us a lot of time, especially when we have many samples to handle. क्या क्या होता है? प्लंगर, टिप इजेक्टर बटन, फ्रिक्शन रिंग, connecting nut, tip ejector, tip holder, tip con pipette, tip pipetting devices. तो थोड़ा क्लियर नहीं है. Okay. Pipetting devices. The pipette's working principle is based mainly on two mechanisms, namely the air displacement method and the positive displacement method. Each type of pipette has a piston that moves inside a capillary or cylinder. A specific amount of air is left between the piston and the liquid in air displacement. Pipettes. In positive displacement pipetting, the piston makes direct contact with the fluid. Pipette tips. Where solids are to be weighed accurately, as for preparing a standard solution, a chemical balance must be used. However, for approximate weighing, a physical balance is good enough. Using a chemical balance is tedious, as first one has to balance the pan, then one has to put glassware and balance it again, and then weigh. In place of this electronic single pan balance is being used. This instrument makes working easy. First we have to allow the balance to zero itself. Then we put a beaker into the pan. Then the weight of the beaker is automatically zeroed, tearing, which then allows us to weigh the chemical. chemical balance, electronic single band balance. Distilled water should always be used for quantitative work. Never dip your pipette in the washed water containing distilled water. Rather pour some water into another vessel, such as beaker or your test tube, and then pipette out from this. In titration work, first reading is likely to be approximate and hence must be confirmed by second reading or third one wherever necessary. The difference between consecutive readings should not be more than 0.1 ml. In all titration work toward the end point, addition should be one drop at a time until the desired color is obtained. In case of doubt about the end point, additional drops should be added to confirm the finding. The result of quantitative work is often expressed in percentages or daily output or in any other suitable units. Some of the substances are best expressed in equivalent or milliequivalent units. 1000 milliequivalent is equal to 1 equivalent. An equivalent or milliequivalent solution is that one in which 1 gram equivalent or milligram equivalent of the substance is dissolved in 1 liter of solution. Milligram percentage can be easily converted into milliequivalent per liter or vice versa using following relationship. Milliequivalent per liter is equal to milligram per 100 ml into 10 by the equivalent weight of the substance. थैंक यू. चैप्टर 7 कंप्लीट हो गया. अब मिलते हैं नेक्स्ट वीडियो में चैप्टर 8 में, प्रिपरेशन ऑफ बफर्स एंड एस्टिमेशन ऑफ पीएच.